Let's solve for the voltage gain of this multi-stage amplifier. And before we begin, we should check to make sure that there's not any problems. For instance, what if this resistance was 1 or it was shorted? The gain would be 0 because everything would the input resistance on that stage would be 0, and it wouldn't matter what was going on in the rest of the circuit. Right? We can see that there's 3 stages separated by these coupling capacitors that couple the AC. Okay, so that's okay. The voltage supplies are all positive here, negative, 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 so I haven't made a mistake there. This sets VG at 0, but with the drain current flowing here, that should put a VGS that turns the transistor into saturation mode. Same thing here, except it would be in forward active. Same thing here, except it would be in forward active. Looking through, I don't have any other concerns where maybe I've made a mistake in the circuit. Okay, so the thing is it might look really complex at first, but ultimately this is just going to be a voltage divider. This is a common source amplifier. This is a common emitter amplifier with some of the emitter resistance shorted out at AC, and this is a common collector amplifier. So we know that the gain of this should be about 1, and that these gains should be greater than 1. All right? So let's draw the small signal model. All right? So the gate to ground, this series resistance is shorted out. The derivative of a power, of a constant voltage is 0. So that goes to an AC or a small signal ground. I have an output resistance that's shorted to small signal ground. And then what's new is that this is shorted and that the input of this transistor is now the load of that transistor. And you can see R pi and RE2. So first equation's easy. VG divided by Vin is just the voltage divider. Okay. Now, rather than calling that V out, I've called it VB2, and that's VG, and that's really minus GM, RO, parallel with RD, in parallel with, hey, what's Rin? It's R pi plus beta RE2. Where that comes from is another video. Then on this stage, all right, this input becomes this one's load, and I call it VB1. So VB1 divided by VD2 minus GM RC2 in parallel with R pi plus beta RL divided by 1 plus GM RE2A, because that's there in the DC. And then the final stage, that's just an easy common emitter stage. How do we get it all, the gain together? You just multiply the stage gains together, and you get a rather long equation, which I will attempt to fit in my camera and hold on to it for a little bit. But really, the math looks pretty intense, or a lot of parallel resistances, but the way to solve this problem was just to know that, hey, there's a small signal model for a MOSFET and a small signal model for a BJT, and you just apply voltage divider rules, adding parallel resistors, and that current flowing across the resistor from positive to negative is V equals IR, and if it's flowing the opposite way, it's V equals minus IR. And so this circuit might appear really daunting at first, but if you apply those simple principles, you'll be able to rapidly come up with this answer.